Our next laboratory exercise is M08, and in this laboratory exercise we're going to start using console input-output. So overall we're going to go over things and experiment with displaying values for the user in console screen from within assembler program, also be able to accept input from the user, and also play with integer addition and subtraction instructions. So this is the agenda for this laboratory. So the tasks of input-output, both of these tasks, are associated with the fact that when we get an input, the input comes as just a string of characters, right? So we always get a string of character ASCII codes. So this could be a numeric value, but the important thing is that we are going to get a string of characters. So we need to be able to accept string of characters from the user by reserving some memory space and accommodate these characters. Then what we're going to do is that we are going to convert these characters to 2's complement value. Very likely the result is going to be in the register. So the step number 1, get string of characters. Step number 2, do a conversion to internal 2's complement format. So once we have it in the register, we can now move it into some memory location to preserve as a normal variable and be able to identify it as a variable that now has a value that we were able to accept from the user. On the output things side of things, what we have is that we probably are going to start with some kind of numerical value inside the register. So now we have to be able to display it as characters for the user. So we need to convert this 2's complement number into a string of characters, again somewhere in memory buffer, and then output, essentially print these characters on console screen. So to begin with, I went to our previous project, week 8, which was also a clone of the previous project. We covered the topic of making a copy of the project in this video 7.13 MASM operators and identifiers. So this video contains step-by-step instructions on to how to make a copy of the previous project and rename it to have it matching our current project name. And so here in my environment I already opened the project, and I went to Solution Explorer and renamed the solution name, the project name, and the main program right here to match our current laboratory exercise. Also notice that once you open the project, sometimes when you delete previous working directories, it switches to x64, which is 64-bit configuration. So make sure that you switch to x86 to avoid unnecessary error messages. Okay, so that's how we want to use it, and normally once you have everything renamed, you just click this button to save everything, the entire configuration. So in this laboratory, we're going to use Microsoft Macro Assembler macros. So the macros are basically expandable macros into series of assembly commands, and what we're going to do is that we use input-output H and also implementation file input-output ASM to interact with an operating system. If you recall from our previous laboratory exercise, we experimented with looking at the modules loaded together with our executable, and we did see DLLs that provide services of the operating system. So in implementation of our input-output, what the program does, it's using Microsoft Windows API to open a standard input as a file and be able to read and write into it. So reading is getting information from the keyboard, and writing is printing information on the keyboard, because it's possible to obtain the handle of the standard input and standard output using Microsoft API. And if you're curious, you can look inside at the code of this implementation file, io.asm, and you will see how it's done. So there's some code written to be able to interact with operating system. Now, to be able to complete configuration of our laboratory exercise, I'm going to jump to the location of my project, which is in this folder, M08, and I will jump to M08 right here, and under source we have the copy of the previous program, but in this laboratory exercise we're actually going to replace the old code with new. And so here what we need to do is we need to you have to locate your source file and copy the path, and what I'm asking you to do is to download these files, io.h, download, just normally just you can say save link as, and point it to your location like this, right? Hit enter and just download it, save. Okay, so you see how it gets downloaded side by side with existing program. Then we're going to notice that I use the download link. Also download link for io.asm. Don't click this, just right click download and save link as, and also save it in this location. And finally we have brand new version of M08. So also right click download link and save link as, and you can see how it prompts me to create a second ASM file, and my browser wants to do this. So but I will click on M08.asm to override it. I just want to replace it with a new version. So you want to replace it? Yes. Okay, so we basically just downloaded two new files, io.asm and io.h, and a demo program that demonstrates how to use these two files. Now here comes a very important step in configuration of our new project, is that we need to add this file io.asm to the new source file, because now we are adding new implementation file io.asm to our project. So instead of having just one assembly module part of our project, we're going to add this one as well, io.asm. However, do not include io.h because it's included by the include directive inside our assembly program. So let's do this. We need to right click on the source and say add existing item, right? And just go back to the source files, right click, add existing item, and make sure that you're pointing to the right place. Under source we have to include io.asm, right? So source files io.asm, just this one. Add it, and once it's added, I typically verify. I just go to it and right click, and I verify in the properties that under Microsoft Macro Assembler, actually configuration properties, general configuration properties, that the item time is indeed Microsoft Macro Assembler, because if it says excluded from build, you have to be able to change it back to Microsoft Macro Assembler. But because we already had one M08.asm file in place, this should be already the default for this project. So I don't have to change anything. I typically just check this. Okay, so this is fine. So now let's verify that we can build this program and see how the build goes. So I'm just going to say build, and you see that now assembling two source files, io.asm and M08.asm. So they're built together just like multiple files in your C or C++ project, that you can build your program from multiple files. So now we are ready to explore the macros which are defined inside our header file. Right here in our main file, we do include io.h, and this header file defines all input-output facilities that we're going to use in this laboratory, and as necessary we can continue using them in our future projects as well.